Hello everyone. In this video, we're going to learn how to commit function model validation. Alright, so we have three different models. The first one is going to be linear, the second one is going to be quadratic, and the last one is going to be exponential functions. Alright, so given a table right here, so we need to plot each of these order pairs on the x and y coordinate plane, and if we see the shape as a straight line, that is a linear model. Okay, so we're going to use a linear model when the data reveals a relatively constant rate of change. Alright, let's take a look at the second one. We need to plot each of these order pairs. Alright, and we see the U shape like this. And then this is actually the quadratic function. We're going to use quadratic model when the rate of change are increasing or decreasing at a relatively constant rate of change. Alright, and the last one, if we plot these order pairs on the x and y coordinate, and we see the exponential shape like this, and this is actually exponential model. So we're going to use the exponential model when the output values are roughly proportional, right? So the outputs right here, this is 1, this is 1.9, and this is 4.2, this is 8.8. So which means we're going to multiply roughly by 2 each times, right? Now let's take a look at the first example. So selected values from several functions are given in the tables below. Sketch the scatter plot for each table, then determine if a linear, quadratic, exponential model is appropriate. Alright, so 0, 11 is going to be right here. 2, 8.2, so it's going to be something right here. 4, 5, so it's going to be right here. 6, 2.3, so right here. And 8, -1, so it could be right here. Alright, so we just get a line, and we see that it looks like a linear, right? So this is linear. Now second one, -1, 2, right here. 1.5, 5.5, so it's gonna be from right here. 4, 10.5, right here. 6.5, 5.75 is somewhere else right here. And the last one, 9, 2.25, so it's right here. And you see that it looks a U shape, right? It looks something like this. Alright, so this is quadratic. The next one, 110, right here. 3, 5.2, 3, 5.2 is going to be right here. 5, 7, 1.3, 4, 5, 6, 7 right here, 1.3, so it's going to be right here. And 9, 0.7, 9, 0.7 is going to be somewhere right here. So if you sketch a line, it looks an exponential function, right? So this is exponential. And the last one, -2, 2, -2, 2, so it could be right here. 1, 3, right here. 4, 4.5, right here. 7, 6.25, 7, 6.75, and 10, 10.25, so it could be right here. And if you sketch a line, it looks an exponential function. So this is exponential function. Now let's move on to the next example. So given the table like this, question number 1, we need to use the regression capabilities on your calculator to find a linear model, right? In the form of y equal a plus bs, right? Now where s be the months after per, okay? Weight is gonna be in kilograms. All right, so we're gonna bring up the calculator. So this is TI and SPY calculator. So we're gonna hit Control I. Alright, so we're gonna pick number for add list and spreadsheet. And then we just input the values right here. So now don't forget to label the S and Y column. So I'm gonna put S here, Y. And then you move your cursor to the plain rectangle right here. You hit menu, start, go to start calculations, and then find number 4 right here, linear regression. Alright, the first one right here you need to put X. The second one right here you need to put Y. This is F1 to have the calculator store your function. Alright, so go down, hit OK. Enter. Alright, so your answer should be right here. Y equals A plus BS, but A equals 3.34 and B should be 0.8. Now, what if we use the TI-84 plus CE calculator? So we're gonna bring up the calculator. We hit Start, Edit. Right, the first column right here, we go up. We hit clear, go down, it's gone. So we just input the values right here, 0 through 4. Now go to the right, go up to L2, hit clear, go down, it's gone. So input the values 3.2, 4.2, 5.1, 5.8, and 6.4. Alright, now hit start again, go to count. Number 8 right here, linear regression, A plus BS. Right, so go to number 8. Hit enter, L1, L2, which means the S and Y column. Now, store regression right here. You need to hit vars, Y vars, function, Y1 to have the calculator store your equation. And then go to calculate, hit enter, and then you get the same answer, 3.34 and 0.8. Alright. Now question B, use the model found in part A to predict the weight in kilogram of this baby 2.5 months after birth. Alright, so basically 2.5 months right here, this is the S value, right? Look, this is S value. So basically you just substitute 2.5 for S right here. Alright, and you have the answer. So Y equals 3.34 plus 0.8 times 2.5, right? Now you bring up the calculator. Hit Control I. Add calculator right here. Alright, so you hit F1. Alright, hit parenthesis. And you put 2.5. close parenthesis, hit enter. The answer is 5.34. So you have 5.34. Now let's move on to question C right here. The actual weight of this baby 2.5 months after birth was 5.5 kilograms. What is the residual of this weight? Alright. Now we look at this one right here. We have the formula right here. The residual equals the actual value subtract the predicted value. The predicted value, we got it right here from question B. Alright, predicted values is the values from the equation right here. So this is P, right? And then this is A right here. Okay, so we have the formula residual equals actual subtract predicted, which means R equals A subtract P. So the trick for you to memorize is R A P, which means RAP. Okay, so if RAP greater than 0, this is underestimated. If RAP less than 0, overestimated. So right here we have residual equals the actual subtract the predicted values. So it can be 5.5 subtract 5.34. It's gonna be 0.16. This guy greater than 0. The model underestimated the weight of the baby 2.5 months after birth. Now let's move on to the next example. So given the table of values right here, question A, find a quadratic regression curve route to the 3 decimal places. Alright, so we just bring up the calculator. Now we hit Control I. Number 4 right here, add list and spreadsheet. Alright, so we input the values 0.5. Now don't forget to label the X and Y columns. Alright, so now you're gonna hit menu, start calculation, and quadratic regression. Number 6 right here. Alright, so this is should be ask. This guy should be Y. And this one should be F3. So you keep that in mind in order to do question B right here. It's not F1 anymore. Then go down to hit OK, enter. So your answer should be A equals negative 1.458, B equals 16.164, and C equals negative 2.195, right? So the function, this is the function A, right? So we have the function A of h right here equals negative 1.458 h squared plus 16.164 h minus 2.195. Alright, so if you use TI-84 plus CE calculator, you just hit start, edit. Alright, now you just input the value right here. Then you hit start, go to count number 5 right here. And go to store, hit VAS, YVAS, function, Y1, hit calculate, and the answer right here. It's exactly the same thing. Alright. Now question B. Use your model from part A to find the error at t equals 10. Alright. So in order to find the error, we need to find the predicted value. Alright. So in order to find the predicted value, you just substitute 10 for h right here. This is actually 10, not t. Alright, into this equation. So you have A of 10 equals negative 1.458 of 10 square plus 16.164 times 10 minus 2.195. Alright, so we bring up the calculator. Alright, so we hit Control I. Right, add calculator here. Now remember that we just store this equation as F3. So we hit F3. Alright, parenthesis 10. Close parenthesis, hit enter. So your answer is 13.629, right? So equals approximately 13.629. Alright. Now we look at the table right here. We see that at h equals 10, right? The actual value is 12. So we have residual value r equals actual value subtract predicted value, which means 12 subtract 13.629. So it's going to be negative 1.629. Now question C. Is the value predicted an overestimate or underestimate of the actual value? So because this guy less than 0, so based on the trick right here, it's going to be overestimated. Alright, so let's move on to the next concept. Using a residual plot to check if the model is appropriate. Alright, so this is a residual plot. A residual plot shows all the residual for a set of data and can be used to help determine if a model is appropriate for a given dataset. Now, if a model for a given dataset is appropriate, the residual plot should appear without pattern. Okay? If a model for a given set of data is inappropriate, the residual plot should appear clear pattern. Alright, so we look at example right here. Example number 3, an exponential function regression was used to model a dataset. The residual plot for an exponential function model is shown right here. Now, we need to determine if each of this one appropriate for this residual plot. Okay? Which of the following is the best conclusion about the appropriateness of the exponential function? So, question A. The exponential model is not appropriate. This is wrong, right? Now, the exponential model is appropriate because the residuals shows no pattern, right? We look at this one, we see no pattern. So, this is the right answer. Alright, so let's move on to the next example. A group of AB Precalculus students use a set of data to create linear, quadratic, and exponential regression. Alright. Now, given the three residual plots above right here, okay, which model was most appropriate for the data? So we look at this one, we see that this has a shape, right? So this is not the right answer, right? It must shows no pattern, right? This guy had a shape, so this is not the right answer, right? This guy has no shape, so this is the answer. So the answer must be exponential regression. Now let's move on to the next example. Now let's move on to the last example. Given the residual plots right here, the given residual plot has a point labeled P at the coordinate 62, 4.7. Alright, what does the point P indicate in the context? Alright, so point P is above the x-axis for the student with a height of 62 inches. The model underestimates the actual number of shots made by 4.7. Alright, so above the x-axis, underestimates. So this is underestimate, right? Question B. The point labeled Q as the coordinate 74, negative 2.4. What does point Q indicate in the context? So because point Q is below the x-axis, for the student with a height of 74 inches, the model overestimates the actual number of shots made by 2.4. Alright, so below the x-axis, this is overestimate. And it's good time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young, it has just begun as she puts her hand